Hi friends, welcome back to Acharya Gurukulam. Today's topic is structural analysis as per IS 456 2025 draft code, a detailed discussion. In this video, I'm going to explain the various methods used for the analysis. Those are the conventional methods, start and time method, and simplified estimate method. Structural analysis is important for civil engineering. It is a process that involves understanding the behavior of structures under various loads and conditions. The primary goal is to ensure that the structures can withstand the force they are subjected to. This includes weight of building materials to the impact of natural hazards such as wind and earthquakes. Understanding material properties, geometry properties, loading distributions, and external environmental factors is very crucial. But safety and long run of structures is a vital. Structural analysis is predicting the performance of structures under different conditions. It is the crucial step in the design and construction process. There are two methods of structural analysis, namely linear analysis and nonlinear analysis. Linear structural analysis can be performed using 3D structural analysis using a valid standard software. 2D structural analysis, which can be done by hand calculations using planar vertical frames in simple structures that satisfy the following. The structure is symmetrical in plan and elevation and subjected to symmetrical loading. The structure has a rectangular plan with an area of 400 meters square and less. The plan aspect ratio of structure is 3 or less, and the structure has a height of 10 meters or less. The structure has a regular structural grid along both plan directions, and these grids are parallel to each other along each direction. The sizes of similar members do not vary by more than 10%, like depth of beams and plan dimensions, etc. Linear analysis shall be performed by any one of the following methods. Number 1, conventional methods. 2, strut and time methods. 3, simplified approach method. Nonlinear analysis shall be used to assess for new structures. Consider accidental and extreme load combinations. For existing concrete structures, all three sets of combinations, that is basic, accidental, and extreme loading combinations, have to be considered. Standard structural analysis software that is publicly valid like SAP, ETABS, only after undertaking a detailed sensitivity analysis of the parameters used to define the inelastic stress strain or load deformation characteristics of the materials and our members shall be used. Now we'll discuss the conventional method. Structures shall be analyzed by the linear elastic, that is the first order analysis method, to estimate internal forces and deformations produced by design loads applied on them using spatial analytical models with material and cross-sectional properties. Under conventional methods, there are subcategories: modeling. In that modeling, member flexibility, that is geometry, material property, and boundary conditions. Second, soil foundation system flexibility. Here, for foundation and soil has to be discretized. And third, effect of pre-stress. Next, loading and analysis has to be done. 3D models shall be employed in the structural analysis with geometry, material, and boundary conditions of the structure captured accurately to reflect the true conditions of the structure, except as permitted otherwise. For member flexibility, the geometry, material properties, and boundary conditions of connectivity between members or members and foundations shall be taken as specified here under in order to capture the flexibility of the structure. For geometry, members of monolithic concrete structures shall be modeled with their center lines and assumed to be rigidly connected to each other. The members shall be considered to span between the center lines of the end members if d1 plus d2 by 2 is less than or equal to L center line divided by 10. Here d1 and d2 are the dimensions of the end members into which the member is framing at its ends, and L center line is the span of the member measured between the center lines of the end members. Else, the members shall be considered to be flexible up to d1 by 6 and d2 by 6 from the face of the two end members, and the rest of the portions of the member within the joint region treated as rigid. In indeterminate structures subjected to load combinations corresponding to strength, serviceability, robustness, and integrity criteria, the relative stiffness of the members shall be based on one of the followings. What are the conditions? The second moment of area of the cracked transformed cross sections, where the transformed cross section shall be considered as area of uncracked part of concrete and area of steel reinforcement bars transformed into equivalent concrete area using the modular ratio M given by M is equal to 300 divided by FCK. Second, the prescriptive values of cracked moment of inertia of members, where the estimation of gross moment of inertia Ig of a beam. The estimation of gross moment of inertia Ig of a beam shall be considered the effects of both beam and a part of the slab, that is equal to effective flange width when slabs are not modeled explicitly. Second, only beam when slabs are modeled explicitly and when the load combinations considered include earthquake loads. As per IS 456 2025 draft code, a tabular column is given for various structural members for various strength design, robustness check, and integrity check, and serviceability check for axial area, shear area, and second moment of area. When safety of a concrete structure depends upon the torsional strength of certain members, that is, the members are required to resist primary torsion, the torsional stiffness of such members shall be considered in both analysis and design. Torsional stiffness of such members shall be included in the analysis. Torsional rigidity GC of such members shall be taken as GC is equal to 0.4 into GC into C effective, where GC is equal to the shear modulus, which is equal to EC divided by 2 into 1 plus nu C, where nu is equal to Poisson's ratio. EC is the modulus of elasticity, which is considered as 10,000 FCK to the power of 0.3. In the earlier version of 456, that is IS 456 2000, the modulus of elasticity is considered as 5000 under root of FCK. Now it is changed into 10,000 FCK to the power of 0.3. And the Poisson's ratio is ranges 0.12 to 0.2 for various types of aggregates. C is the torsional constant, which is equal to 0.5 K, and K is the Saint-Venant torsional constant of gross plane concrete sections of rectangular web without considering the flange, which is equal to alpha into D BQ, where B is equal to smaller dimension of the member and capital D is the larger dimension of the member, and alpha is the factor to estimate Saint-Venant torsional constant. Here a tabular column is given depending on the ratio of the capital D divided by small b for alpha. So it ranges from 1 to 5. The alpha values are given. Alpha means a factor to estimate the Saint-Venant torsional constants. Now here you can see in the estimation of deflections in structures, the moduli of elasticity, EC, ES, and EP of concrete reinforcement steel and pre-stressing steel shall be taken as EC. It is for concrete, that is 10,000 FCK to the power of 0.3. ES is 200 into 10 cube MPa. It is for all grades of steel, and EP is equal to 210 into 10 cube MPa for cold drawn wires, 200 into 10 cube MPa for high tensile steel bars, 195 into 10 cube MPa is for strands. Next, boundary conditions. When modeling the When modeling, the connections between members shall be considered to be rigid, while those between a column and column bases shall be considered to for flexible. If the column terminates into an individual footing resting of flexible soil, that is where the flexibility shall be reflected by elastic springs, whose translation and rotational stiffness shall be estimated considering the flexibility of the footing and the modulus of subgrade reaction of the soil underneath. And second one is rigid if the column terminates into a raft. Next, soil foundation system flexibility. The flexibility of foundation of the structure and soil underneath or adjoining shall be accounted for, especially in large structures resting on for open foundations, that is other than piles, resting on soft soil sites, that is site class D and E, and deep foundations other than wells and caissons resting on medium and hard soil sites, that is site class A, B, or C. These soil classifications as site classes, these site classes A, B, C, D, and E are discussed in IS 1893 part 1 2025 draft code. For foundation flexibility, the flexibility of the structural elements composing the foundation of the structure shall be modeled considered their geometry and material properties. For soil flexibility, when soils are soft, ground improvement methods shall be employed. The flexibility offered by the soil underneath on which the foundation of the structure rests and the soil adjoining the structure shall be modeled. Next, effect of pre-stress. When a concrete structure is pre-stressed, that is partially or fully, structural analysis of the whole structure shall be performed by considering the force effects of pre-stressing in determinate structures and both force and displacement effects of pre-stressing in indeterminate structures to account for impact of pre-stressing on adjoining elements. Whereas in indeterminate structures, a finite element method, that is FEM, shall be prepared of the members and the structure where forces are transferred between the tendon elements and fiber elements along the full length of the member through the bond elements. Next, loading conditions. Loads shall be applied as per the load combinations given in IS 456/2025 draft code. It is used table 3 of IS 456/2025 draft when designing to meet the strength criteria, table 4 to meet the serviceability criteria, table 5 to meet the robustness criteria, table 6 to meet the integrity criteria. Table 3, 4, 5, and 6 of IS 456/2025 draft code is applicable when checking compliance with the restorability criteria. So these criteria are discussed in the previous video of IS 456/2025 draft. Next, analysis. So in that analysis, the stability index, that is QS at story S, shall be estimated as QS is equal to the ratio of sigma C is equal to 1 to NCS PDC and delta DC divided by sigma C is equal to 1 to NCS HDC multiply with HS, where PDC is equal to the design axial force in column C in the story considered, and delta DC is the lateral deflection at top of column C with respect to its bottom in the story considered along the principal plane directions considered. HDC is the lateral shear force at top of column C in the story considered along the principal plane directions considered. HS is equal to height of story considered, and NCS is the number of columns in the story considered. The same stability index equation is given in IS 456 2000 in the appendix. The largest value among all, the largest value of stability index Q max among those values of all stories NS stories of the structure shall be taken into account for the analysis purpose. A tabular column is given here for various cases with various load combinations. A method of structural analysis applicable to the three sets of load combinations. So the three sets of load combinations are basic, accidental, and extreme. And in the method of analysis, linear analysis and approximate geometry nonlinear analysis, geometry and material nonlinear analysis. Now, based on the stability index, that is Q max, so if the Q max is less than 0.04 for basic load combinations, for designing basic load combinations has to be considered for designing of the structure. For accidental load case, no need to consider. For extreme loading cases, for extreme loading combinations, linear analysis has to be considered for designing the structure. Similarly, if the Qmax value is in between 0.04 to 0.1, then basic load combinations and extreme load combinations has to be considered. For if the Qmax value is greater than 0.1, that comes under geometry and material nonlinear analysis. For basic load combinations, one has to redesign the structure to reduce the Q value to be less than 0.1, and accidental load combinations and extreme load combinations has to be considered. Linear analysis, it may be performed of concrete structural systems when stability index QI is less than 0.04, as I discussed in the previous slide, and the slenderness ratio lambda is equal to KL by R of all columns satisfying lambda is equal to 20 for columns not braced against side sway, and lambda is equal to 40 for columns braced against side sway, and lambda is equal to KL by R, and R is equal to the radius of gyration. This radius of gyration is to be considered for rectangular cross sections 0.3 times the dimension of cross section in the considered direction of deformation. For circular cross sections, the value of R is to be considered 0.25 times the diameter of the circular cross section. Linear analysis may be performed using the four methods. One is the frame method, finite element method, hybrid method, and struct and tie method. So, in frame method shall be used when structures consist largely of members that have one dimension much larger than those other two. Finite element method shall be used when structures consist of members that are that have only structural walls and slabs. The approximateness of the results from this analysis shall be ensured before considering them in design. Stress concentrations at points of applications of concentrated loads and reentrant angles or corners and openings in slabs shall be addressed in the design stage. For hybrid method shall be considered when structures consist of mixed structural systems and members of uneven geometry, that is D beams or maybe beam column joints with similar sizes. Some members may be modeled as frame members by their centerline geometries. uh, all requirements related to the modeling of the structure specified in the frame and finite element methods shall be applicable here. For structure time method shall be considered when structure consists of complex load paths, non-uniform stress distribution in non-prismatic members and junctions of members of concrete structures. This method is meant to perform local analysis and shall not be used as a substitute for overall global structural analysis of the structure. In each of the methods mentioned above, it shall be ensured that the geometry, that is the area of cross sections and moment of inertia of members is consistent. Modulus of elasticity is considered as specified above. Mass is represented accurately when dynamic actions are to be considered. Boundary conditions reflect the true restraint at the supports. Effects of shear deformations are considered when estimating the stiffness of the members whose L by D ratio is less than 10. This requirement shall not be applicable for slabs. For nonlinear analysis, material and geometry nonlinear analysis shall be performed of lateral flexible concrete structural systems. Nonlinearities occurring in the structure shall be considered under the action of loads specified in the load combinations when checking for the compliance of the structure with robust integrity and restorability criteria. Progressive collapse analysis have to be considered. Under this, there are two categories. One is local collapse and global collapse. Local collapse involves formation of plastic hinges of a few adjoining members, resulting in that local portion of the structure to become unstable under the inelastic condition and unrestricted deformation under the applied loads. For global collapse, which involves the formation of plastic hinges of all members and the structure, resulting in the whole structure to become the unstable under the inelastic condition and unrestricted overall deformation under the applied loads. The last one is blast load analysis. For progressive collapse analysis, the procedure is as follows. The first step is identifying all key elements of the primary load resisting system of the structure. Next, preparing the analytical model, removing one key element at a time, performing a linear structural analysis of the residual structure to estimate the design strength demand on the remaining members under the applied gravity loads for basic load combinations, repeating the analysis, removing another key element until the key elements are removed at one time. Listing all load combinations of stress resultants, that is P, V, M and T on each member of the structure from each of the above analysis and shall be used to design the members. Next, strut and tie method. For modeling, a member or local region shall be represented by a strut and tie model, which consists of traditional truss made up of struts and ties connected at nodes, capable of transferring the factored loads applied on them. The important requirements of this method are as follows. At each node, at least three members meet, that is, at least three struts, two struts and one tie, and one strut and two ties or three ties. The ties shall be permitted to cross struts without touching each other, but the struts shall cross or overlap only at the nodes. When determining the geometry of the truss, the dimensions of the struts, ties, and nodal zones shall be considered into account. The angle theta between the axis of any strut and any tie meeting at node shall not be less than 25 degrees. The area of each face of the node shall not be less than the cross-sectional area of the strut or tie measured perpendicular to it, and the shape of each face of the node shall be similar to the shape of the projections of the end of the struts onto the corresponding faces of the nodes. For geometry properties, the geometry properties of the struts and ties shall be taken as for strut cross-sectional area, AS of the strut shall be estimated as the product of its width, that is BS, and depth, capital DS, of confined concrete within the transverse reinforcement shall be taken as BS is equal to breadth of the member under compression and DS is equal to 0.25 times of the length of the member under compression. For tie cross-sectional area, AT of the ties made of steel reinforcing bars shall be taken as sum of cross-sectional areas of all bars in the members transformed to equivalent area of the concrete. For material properties, the material properties such as modulus of elasticity or Poisson's ratio, compressive strength, and tensile strength shall be taken as for struts. The properties shall be taken as that of the concrete is confined by appropriate closely spaced closed loop transverse steel reinforcement. For ties, it shall be taken as that of the longitudinal steel reinforcement bars. For loading, the loads and load combination shall be considered for strength, design, robustness check and integrity check. For analysis, the traditional linear truss analysis shall be performed under the action of applied loads and the forces estimated in the struts and ties along with the supports reactions. The last one is a simplified estimates method. Unless more accurate estimates are available, uh, from computer-based analysis as per IS 456 2025 draft, provided all conditions mentioned here are satisfied, the following simplified estimates shall be used of. These simplified estimates shall stand as the lower bound values for the results from the conventional method and strut and tie method of the structural analysis. Second, the effective length of the concrete compression members as specified. Third, the deflection of the crack widths in concrete beams as specified. Thank you. Jai Hind.